further process. In the last class, we were discussing about the uh, derivation of fast Fourier transform. Okay, from we got to know how to divide the sequence of x of n into even sequence and odd sequence. Further, followed by we have derived the sequences for n by 2 point DFT. So by dividing n point DFT into n by 2 point DFT, how it is possible to obtain the DFT of a given signal. Now today we will once again divide the n by 2 DFT into once again n by 4 point DFT. Okay, so directly I'll share the screen now, and today we'll try to finish off the derivation part. Please stop me if you are not able to understand at any point of time. This was the discussion in the last class that what we made, right? So x of n sequence will be there. The a sequence of x of n signal are divided into even signal and odd signal. Okay. So this is x of 0, x of 2, x of 6, 4 and 6, and this part is even signal. Even signal of x of n. X of n.
Screen is not visible, sir.
Screen is not visible. Let me check. Okay. Is it okay now?
Yes, sir. It's okay, sir.
Thank you. So this x of n, given x of n, given any point x of n. So this x of n, entire x of n is divided into the even sequence and odd sequence. Okay, so when I divide the sequence, now assume that I have chosen n equal to 8 point TFT. When I say that 8 point DFT, so I will going to get a first four sequence as even sequence as 0, 2, 4, 6, which is nothing but here that will be 4 point DFT, right? So I'll calculate the 4 point DFT first. Then once again, I use the 4 point DFT itself to calculate rest of the odd sequences x of 1, x of 3, x of 5 and x of 7 as such. Now here whatever the output I get, as I told you, this part I will be considering it as g of k, okay, and this part is with respect to h of k. And you already know that how we're going to get this g of 0, g of 1, g of 2 and g of 3, right? So how do you obtain g of 0, g of 1 and g of 2? That's what like so if I want to get x of 0 is obtained by like, now this will be, I'll call it as g of 0 and g of 1 and g of 2, the output, okay, of even sequence, okay, 4.6. Now here I will be calling this as h of 0, h of 1, h of 2 and h of 3. Fine. Now, to obtain x of 0 signal, what I will be doing, you already know that x of k, first n by 2 point of DFT is given by x of k plus wn k h of k. This is what the derivation part that in the last class we discussed about, right? So again for the next, this is for 0 to n by 2, then n by 2 to n minus 1, it is simply a periodic version of g of k and h of k, that is g of k minus n by 2 and h of k minus n by 2, right? So in such cases h of 0 is going to be obtained as just h of 0 is nothing but g of 0 is multiplied with No, see here. Okay, first is I'll just h of 0 is multiplied with w 8 to the power of 0. So n is 8 here in this condition, and first sequence, that is k, is 0. So that is what w 8 to the power of 0 is multiplied with h of 0, and then again it is added. You are supposed to perform addition operation here. It is added to get x of 0, right? So similarly, next case, that's what the x of 0 signal. The next, x of 1 signal. X of 1 signal is obtained. So again same thing, w8 to the power of 1, k value is 1, h of 1. So these two values are multiplied, followed by g of 1. Similarly, I calculate x of 2 and x of 3, right? Then now the point is, how do you calculate rest of the signal? That is, so because here itself it ends, what is that, 0 to 3, because n 0 to n by 2 point DFT only, right? So now I need 8 point DFT output. So what we do? So x of k is nothing but g of k minus n by 2. G of k minus n by 2 means x of 3 equal to how much? X of 3 Allah. X of 4 equal to how much? It is nothing but g of 4 minus n by 2 is nothing but again 4. So this will be g of 0 plus w8 to the power of 4 h of 0, right? So this signal this signal x of 4 is nothing but h of 0 is multiplied with w8 to the power of 4. As I told you in the last class, wn to the power of n is equal to wn to the power of n by 2. That is, in the last class it is solved. So wherever w8 to the power of 4 occurs, it is nothing but minus w8 to the power of 0, right? So this is equal to this. So now I will simply minus the value h of 0 and w8 to the power of 0. These values I already calculated. Now I simply negate them, which is nothing but subtraction. The g of 0 value, x of 0 is x of 4 is nothing but g of 0 minus w8 to the power of 0 h of 0, right? Similarly, x of 5 is nothing but x of 5 x of 5 is nothing but g of 1, right? So here when you substitute k minus n by 2 and k equal to 5, you will going to get g of 1 plus w8 to the power of 5 g of h of, sorry, it is h of 1. Now what is w8 to the power of 1? Can I write w8 to the power of 5 is equal to w8 to the power of 1 into w8 to the power of 4? Yeah. Now we already calculated w8 to the power of 4. What is that? It is minus 1. So which is nothing but w8 to the power of 5. I can simply replace it by w8 to the power of 1. So I already have w8 to the power of 1 here into h of 1. That value I'll subtract with minus 1, and then I'll going to get and with g of 1. So g of 1, this will be the final will be g of 1 minus, instead of w8 to the power of 4, I replace it by its equivalent value by taking minus w8 to the power of 1 and into h of 1. So this is what I'll going to get x of 5. Similarly, x of 6 and x of 7 are calculated by multiplying. X of 6 is equal to h of 2 into w8 to the power of 2, which is going to be subtracted with g of 2, and the same thing is true with x of 7. Okay, now what in general, please listen carefully. I have a input signal x of n. Input signal x of n is divided into even signal and odd signal. Okay. Now we calculated n by 2 point of DFT by the formula method. That's what we have done. Now in the next stage, this is first stage I call. Okay. In the next stage, what we do is once again this is n by 2 point of DFT. Once again, I divide. I take this as a one sequence. One sequence. I try to decimate this. I try to decimate this in terms of even and odd. Once again, here itself. So in this case, the zeroth signal is this first, second, and third, right? So within this, if I want to bifurcate or decimate, how do I do? This is x of 0 and x of 2 as even signal, and x of 4 and x of 6 as odd signal, right? Again, in odd sequences, again if I want to decimate this entire signal, how do you do it? So let me decimate this. So in order to decimate, so I will take x of 1 as odd, x of 5 as one more odd signal. Sorry, even signal. This is even signal. Next odd is x of 3 and x of 7 is odd within the odd sequence of x of n. Once again, what we did, we decimated the sequence x of 1, 3, 5, 7 into even signal and odd signal, right? So once again this sequence will be n by 2 by 2, right? What does it mean? N by 4 point DFT. So let us try to analyze that. So we'll move to the next point where, so let x of n or we already derived this g of k value. I'll just write this. So we already know g of k, and g of k is equal to what? So summation of g r wn to the n by 2 point ft here, right? So kn. So this was the derivation, and the summation range is from r ranging from 0 to n by 2 minus 1. Similarly, we also have a one more equation, that is h of k, where h of k is equal to h of r plus 1, h of uh, k, h of k, so that is equal to h of r into wn by 2 kn. So r is once again 0 to n by 2 minus 1. Here we have 0 to n by 2 point of DFT, and h of k will give you the value of n by 2 to n by 2 to n minus 1. So that's what n by 2 point DFT and one more n by 2 point DFT, right? So now what I do is, so let me call this as equation number one for today's session. For today's session, okay. Let us call this as equation number one, and let me take the g of k here. G of k is, now what is g of k? How many point DFT it is? It is not n point. It is n by 2 point DFT. Okay, now what we do? So GR of n is the sequence. GR of n is the sequence. GR will be consisting of what? G of 0, G of 1 as such, right? So in general, your actual input signal, if I try to write, so this will be x of 0, x of 2, x of 4, x of 6, and so on, because it consisting of only even sequences of your input. So in that, once again, I am trying to split into even and odd. So if I want even sequence, now how do you divide the even sequence? The signal starting range is from 0 itself. Okay. Now the last point the last sequence, the last even sequences is how much? N by 2 uh, minus, yeah, so the last value, the last even sequences will be not n by 2, it is uh, n by n by 2, yeah, n by 2 minus n by 2 minus 1. Okay, now this is only even sequence, so even sequence means which will be multiple times of 2 wn kn plus again here the sequence your n value, so your n value will be in terms of, the n value will be in terms of 2r, which is nothing but I'm considering or fetching only multiples of 2 because I need even signal, right? So similarly next is r equal to 0 to n by 2 minus 1. So minus 1 g of what we should do here, I need odd signal. When I say that odd part of this signal, it is nothing but 2r plus 1, right? So 2r plus 1. So r is already taken, I cannot take here r. So what I do is I'll just replace r by l. R already is considered, it is present. So this, let me take another variable L. Okay, now Wn to the power of how it is going to be varied, k into 2 times L plus 1, right? So that is the last value of your L in case of odd sequences. Now again, see here the range is from R, but inside the value is one more variable L. I need to map my summation limits with respect to the dependent variable. The dependent variable in this case is L. So which means that put r is equal to 2l. Okay, what happens to the limit when l equal to 0, r equal to 0? So if r becomes 0, l becomes 0. What is the last point? R equal to, if r equal to n by 2 minus 1, what is the value of l here? L equal to R by 2, right? L equal to R by 2. What is R in this case? N by 2 minus 1 by 2. What happens to this? It is almost N by 4 minus 1, right? So this is what we're going to get. And now I replace the first summation with summation. Instead of r, I'll put it as L runs from 0. The last value is n by 4 minus 1 g of 2L into Wn 2lk plus I take out wn to the power of k outside, because here wn to the power of k, see this part I'll multiply in such a way that wn to the power of k into 2l plus wn to the power of k. Fine. So this is depend upon L and it depend upon my summation. But whereas Wn to the power of k has nothing to do with the limits. So that is independent. So let me take Wn to the power of k outside. So again, if you put here, if you put r is equal to 2l plus 1, and now if you say that if r is equal to 0, the value of l is also 0. If r is equal to n by 2 minus 1, you just cross verify, l value will be also equal to n by 2 minus 1. So therefore my once again limits will change from r to l, that is 0 to n by 4 minus 1. So here it is g of 2l plus 1 into wn to the power of k into 2l, right? So this all about this. Okay. Now you know that w n to the power of w n to the power of 2l can be written as wn to the power of 2l can be written as w to the power of l by n by 2. So this is what in the twiddle factor in the last class we have understood this. So therefore once again I replace this w summation l runs from n by 4 minus 1 g of 2l. I replace this n by this is n by 2 point EFT, right? I'm sorry. So this is n by 2 point EFT. So this is n by 2. Here the definition is n by 2. So here also it is n by 2. Here also it is n by 2. Here also it is n by 2. This is n by 2, this is n by 2. Now this I can write it as wl to the power of l into k, and I can write this as, in this case if I write in this wn to the power of 2l as wn by 2, if there exists n by 2 in the original equation, then I can write it as n by 4. So this is wn to the power of Lk, where it is n by 4 point DFT, Wn by 2 as it is k, summation L runs from 0 to n by 4 minus 1 g of 2L plus 1. So again Wn, I can take this 2 here, so therefore Wn by 4 KL. Is this clear? So this a of 2 g of 2l I'll just replace with some other name, and let me call it as a of l, and I'll call this as b of l for the times being. So therefore my final equation for g of k can be rewritten as, so look at this. So original equation is n by summation L runs from 0 to n by 4 minus 1 a of L into w n by 4 L into k L k, okay, or KL plus w n by 2 k into summation L runs from 0 to n by 4 minus 1 b of L, okay, and w n by 4 point DFT LK or KL. How do you look like, how it looks here? The definition of x of k is, x of n wn to the power of kn, right? So therefore the here also n, therefore summation was ranging from n equal to 0 to n minus 1, but in this case it is starting with l. So this is L equal to 0 to n by 4 minus 1, and instead of x of n I have a of L, and instead of wn I have n by 4 wn by 4 to the power of kl. So now this equation, can I call this as n by 4 point DFT? This is n by 4 point DFT, and once again this portion is one more n by 4 point DFT. This is one more n by 4 point DFT. Therefore, I simply write this g of k is equal to, I take this as a of k, capital A of k, plus this is capital B of k multiplied with one more factor, that is wn by 2 to the power of k. That's it, right? So this is the n by 4 point DFT, which comprises of the values 0 less than the value k value, that is g of k value will be less than n by 4, right? So which means if I consider 8-point DFT, if I assume n equal to 8, then g of k will be only 2. What about rest of 2? That is nothing but g of k minus n by 4, right? G of n minus k by 4. Oh, there I'll going to get k minus n by 4 rest of the point, then wn by 2 to the power of k b of k minus n by 2, because the values are due to periodicity property. So once again n by 4 k and less than n minus n by 2 minus 1. So I got 4-point DFT from this now, right? Here 2-point DFT values, here 2-point DFT values. In total, from G of k, I should get for G of k, I should get 4-point DFT. I got it. Now, what about, but if I consider n equal to 8-point DFT, then again I should have 4 more points, right? That is, similarly, I can write h of k. H of k, I can simply rewrite. So here a and b are used. So let me take c of k plus wn by 2 k c of this is not c of k, d of k. Okay. Now this once again will give me 4-point DFT, that is running from n by 4. Right. Again, the rest of the 4 values are periodicity follow the property of periodicity. So once again, this is h of k minus n by 4, that is equal to c of k minus n by 4 plus wn by 2 k c of k minus n by 4. Okay. So here once again, from n by 4 to k equal to n by n minus, so this is n by 2, so here n by 2 minus 1. So here once again, here this is 4-point DFT here, and here 2-point DFT, and this is 2 more point DFT. So in total I got 8-point DFT. 2 point once again formulates the 4-point DFT here, and here 4-point DFT. Finally I could able to get from, see, already I know how to calculate g of k and h of k from the previous class. Now, by using g of k and h of k, I just calculate the values of x of k values. Okay. Now, once again, I will make you the point clear. From x of n values, see, I should calculate x of k. X of k values are calculated by splitting n point to n by divided by 2, that is n by 4. Again n by 4 point DFT is divided by 2 or decimated into 2 point, that is n by 4 point DFT. So you know that, take a of k and b of k, calculate g of k. Once you get a g of k values, again you can calculate the x of k values from g of k definition. Okay. Similarly, you calculate C of k, D of k. From C of k, D of k, you can calculate the H of k values. I will make this job very, very simple by applying the chart. By applying the butterfly part. So let me come back to the Google Meet and just okay, look at this. If I consider 8-point DFT, x of n is equal to, let me consider, this is x of 0, x of 1, and up till x of 7 is a 8-point DFT. We already decimated this into even and odd, that is in the form of x of 0, x of 2, x of 4, and x of 6. Then the odd sequences as, this is even sequence, and the odd sequence as x of 1, x of 3, x of 5, and x of 7. Right. Again, what we did, we decimated this even sequences into even and odd. That is x of 0 and x of 4. Okay. So this is evens even signal, and this is even's odd signal. Within even sequences, odd sequence. Then again here within odd sequence I took a even signal, that is x of 1 position, and that is based on the position. Now this will be 0th position, this will be first position, this will be second, and this will be third, right? So in that position of that particular input signal, right? So here x of 1 and x of 5. So again odd sequences, odd position, that is x of 3 and x of 7, right? So here we applied n by 2 point DFT first. N by 2, n by 4 point DFT. N by 4 means 4 divided by 8, 8 divided by 4, that is 2 point. So that the input sequences in the first stage will be x of 0, right? X of 4, right? Again, this even and odd. First is even, within that even once again even and odd. That is once again 2 point DFT. There I consider the next sequences, that is 4 and 6. Sorry, x of 2 and 6. X of 2 and x of 6. Fine. So what we did, we gave this signal to 4 point DFT convert, where we obtained the DFT of this in the fashion of first a of 0, that is a of k values I am talking about here, a of 1 value. Now followed by this 2, this point DFT, that is output of this is b of 0 and b of 1. Now how do you obtain? The first thing is I should obtain g of 0, g of 1, g of 2 and g of 3, right? Later on I will think about h of k and h of, from that I will be obtaining the uh, h of x of k's. But to obtain g of k, how do you obtain the g of k? Let me go back and see here. How do you obtain the g of k? A of k into some twiddle factor b of k. Okay. So for 8 point, what will be this? For 8 point, I'll fix it. W 8 is, if I put 8 here, then this is W4 to the power of k. Right? Now, next case. So this is a of 0 is multiplied with what value? W4 to the power of 0 into a of 0 plus a of 0. This is addition process that we perform here. G of 0 is equal to, I'll just go back one slide. Look at this, observe carefully. For first case, g of 0 is equal to a of 0 plus w4 to the power of 0 b of 0. Once again, let me go to signal flow graph. This is, I call it as signal flow graph or butterfly diagram. What is this? Butterfly diagram. So here b of 0 is getting multiplied with w4 to the power of 0. Further, this signal is getting added with a of 0, so that I will going to get g of 0. Am I clear? Now, once again, second sequence g of 1. How do I get g of 1? As usual, b of 1 is multiplied with w4 to the power of 1. K value is 1. B of 1, w4 to the power of 1. Once again, this is going to be added with a of 1. Okay, that's fine. What about g of 2? How do you get g of 2? G of 2, look at this. G of 2 is nothing but g of 2, that is k value minus, this is once again put n equal to 8, this is once again 0, which is nothing but again g of Rest of the k values are the rest of the g of k, that is g of 3 is obtained, g of 2 is obtained by a of 0 plus w4 to the power of value is 3 b of 0, right? Just as such, I'll just use the separating. Okay, now look at this. G of 2 is nothing but a of 0 plus b of 0. This is going to be multiplied with w4 to the power of g of 2, w4 to the power of 2. So I just take this and I'll multiply w4 to the power of 2. In the last class I told you, look at this, w4 to the power of 0, which is nothing but w4 to the power of 0 can be written as w2 to the power of 0 is equal to 1, right? So now instead of this, the and w4 to the power of 4 is equal to minus w4 to the power of n by 2, that is 2, right? Wn to the power of n is equal to minus wn to the power of n by 2, right? So here I can simply reverse this as this is 0 1 2. Okay, w4 to the power of 2, I simply reverse this as minus 1, or keeping w4 to the power of 2, keeping this instead of, I will be keeping this as a minus 1. And once again, g of 3, how do you get the g of 3? It is nothing but a of 1 plus w4 to the power of 3, k value is 3, b of 1. So which is nothing but I take a of 1 and I add it with, first I will be taking b of 0, b of 1, b of 1 is multiplied with w4 to the power of w4 to the power of 3, which is nothing but w4 to the power of 2 into w4 to the power of 1, right? So we already know that w4 to the power of 2 is nothing but minus 1. I can write this as w4 to the power of 1 itself. I already calculated w4 to the power of 1 while calculating g of 1. I simply multiply with minus 1. Is this clear? Is this clear? Okay. I'll just rub this few things here. Okay. Now, from this we could able to find. So now, after obtaining g of 0 and g of 1, g of 2, g of 2, this will be the inputs. These will be the inputs to find what? To find x of 0, x of 1 and x of 2, right? So from g of 0, g of 1, g of 2, g of 3. From this I can able to calculate x of 0, x of 1, but I need h of values. So now this is only I consider x of 0, x of 4, x of 2, x of 6. That's it. but now rest of the values I need it. Rest of the odd sequences still it is pending itself, right? So within odd sequence, the next first even sequence is x of 1, x of 5, and here it is x of 3, and here it is x of 7. So again it is 2-point DFT. Again it is 2-point DFT. See here 8.2 plus 2 plus 2 plus 2. If you consider this is 8-point DFT, we have divided in terms of n by 4-point DFT. N by 4. That is 2-point DFT. It is going to be divided. Now again these will contribute for me to calculate h of values, right? So I'll going to get from this I'll going to get h of 0, h of 1, h of 2, h of 3. How do you calculate h of k values? Go back. H of k values is calculated from C of k and D of k. So from this 2-point DFT, so I will be getting C of 0, C of 1 and D of 0, D of 1. Fine. So now to calculate D of H of 0, it is just a multiplication of D of 0 with what? W4 to the power of 0, right? So again I replace to calculate h of 1, h of 2, h of 1 is calculated with W4 to the power of 1, W4 to the power of 1. Now here to calculate h of 2, it is nothing but W4 to the power of 2, and W4 to the power of 2 is nothing but minus W4 to the power of 4, which is nothing but 0 itself, right? W4 to the power of 4 is what? 0. 1, I'm sorry. So this is nothing but 1. W4 to the power of 4 is minus 1. So I can replace this here itself with minus 1, and therefore h of 2 is equal to D of 0 minus W4 to the power of 0, that is equal to into so just a minute. H of 2 is equal to C of 0 minus W4 to the power of W4 to the power of 2, or else I plus W4 to the power. Let me write this completely and then later on it is helpful for me to explain. And this is D of 0. How do you replace this? I simply replace this by minus 1, right? So therefore this is Z of 0 minus W, this is minus, so minus of what? Minus of W4 to the power of 2. So already we calculated W4 to the power of 0. We already calculated this W4 to the power of 0. So W4 to the power of 0, it is already present, that is into D of 0. Similarly, h of 3 is nothing but D of 1 multiplied with, so this is equal to C of 1 plus W4 to the power of 1, D of 1. What is W4 to the power of 1? W4 to the power of 1 can be written as W4 to the power of 3. sorry, w4 to the power of 3 can be written as w4 to the power of 2 and w4 to the power of 1. So we w4 to the power of 2 is how much? Minus 1. So that is equal to w4 to the power of 1. So simply it is a minus. I replace this by minus w4 to the power of 1 into d of 1. So that's how we calculate the value of h of 0, h of 1, h of 2, h of 3. Okay, the last stage here. We almost at the end. Now I need to calculate the final x of k here. So how do you calculate? So this I continue. Okay. Now here it is x of 0. How do you calculate x of 0? G of 0, h of 0. Right? G of h of 0 into, so here it is 4 point. Now it will be 8 point. W8 to the power of 0. W8 to the power of 0. X of 0 is what? G of 0 plus W8 to the power of 0 into H of 0. Fine. X of 0 first value. The next x of 1 is calculated. H of 1 W8 to the power of 1 is multiplied and then added with this value, that is g of 1. X of 2 is, how do you calculate? H of 2 into W8 to the power of 2 plus G of 2. And similarly, W8 to the power of 3 into H of 3 plus G of 3 will give me X of 3. Now x of 0 is calculated, x of 1, x of 2, x of 3 is calculated. So now here it is with respect to n by 2 point DFT, that is 4 point DFT. By using 4 point DFT, this second stage I am trying to calculate, that is x of 4. Now x of 4 is calculated as g of k minus n by 2, that is nothing but again g of 0 plus w8 to the power of 4 here. It is w8 to the power of 4. So w8 to the power of 4, I can simply replace this by minus w8 to the power of 0. Right? So this is nothing but here. Here I simply say minus 1. I simply say minus 1 h of 0 in into w minus, I multiply these two and I subtract it from g of 0. X of 4 is calculated as g of 0 minus h of 0 into w8 to the power of 0. That's it. And here also g of 1 is obtained, x of 5 is obtained by h of 1 into w8 to the power of minus 1 and subtracted with g of 1. Again here also x of 6 is obtained as this. I simply minus, negate this, multiply h of 2 and w8 to the power of 2, negate this and subtract with this. Here also I take minus g of 3 into w8, h of 3 into w8 to the power of 3, subtract it from g of 3 to get x of 7. So this is how you are supposed to perform the calculation. Students, note one thing: your input and output are bit reversal order. What do you mean by bit reversal order? See here, input is 0, 4, 2, 6, 1, 5, 3, 7. Look at this. I write output in binary form 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Look at the input. Input is x of 0. Okay, no doubt. It is bit reverse. X of 1. X of n is output. For x of 1, what should be the input sequence? Bit reversal order 1 0 0. That is x of 4 1 0 0. So x of 0 I should take first. The order, how do you take the input order in a DIT-FFT method is take the input x of n in a bit reversal order or x of 0, x of 4 in such cases. Look at this 0, 1, 0. If you go for bit reversal order, it remains 0, 1, 0 itself. X of 3, when you take a bit reversal order 1, 1, 0, 1, 1, 0, that is x of 6. So similarly, x of 4 1 0 0. If you take the bit reversal order 0 0 1, you get the input. So similarly here also, so even for x of 3 and x of 7 in DIT-FFT method, input sequence is bit reversal order and output x of k will be in the regular order. That is one more important point that you are supposed to remember. I hope you could able to understand the butterfly diagram. In the next class, I'll try to solve one example. Here, one more concept is involved here. We change this W4 to the power of 1 even in terms of W8 itself. I know there might be little confusions, so that's why I'm stopping here. And once again, I'll come up with in the next class. I'll teach you once again this butterfly diagram. Once again, you just go and see to the textbook as well as your notes and come prepared. Once again, tomorrow we will discuss this in depth and we'll solve one more example so that you will be comfortable. Okay, one or two examples I will be solving on this so that you will definitely you will going to satisfy with these types of problems, and these types of problems will be asked not less than 10 or 12 marks. Okay, only thing is you should be very pakka with your calculations. Okay, let me come back.